Hello everyone, my name is Shatanti. I'm a second year medical student and I'll be taking up this session about magnetism, some questions related to it. Okay. So the first question says here that a positively charged alpha particle projects towards the west and is deflected towards the north by a magnetic field. The direction of the magnetic field is. Okay, so keeping in mind all the rules that we have learned till now, Fleming's left hand rule, Fleming's right hand rule, thumb rule, and we've also discussed about how electromagnetic induction occurs in its application towards electric motor or electric generator. So now you have to basically apply these concepts here. So now first you have to see what all information is given to you. Positively charged particles, so here since there is not a mention of current, you have to consider that this anything with a charge will produce current. So here the positively charged particle is the current here, and you have a magnetic field, but we don't know what it is. What we do know is that there's a deflection towards the north. The deflection means here there is a motion towards the north, right? So with that information we can apply Fleming's left hand rule here, right? So before that, let's just draw it once quickly. So positively charged particle towards the west, thrown towards the west and deflected towards the north. So this is the magnetic, so this is the deflection or the motion, you can say, and this is the current, you can say. So by Fleming's left hand rule, we know motion, we know this is the current, right, the second finger, and we know the first one is the direction of the magnetic field. So here we have got two, right? So yeah, so if this is the motion happening, and this is the motion upwards, and this is the current is towards the west, then our logical explanation is that the magnetic field is towards the east. Okay. So now, which source produces alternating current? So if it is not given in any book, so it's just better for you to note it down here. So nuclear power plant, thermal power plants, hydroelectric power stations. So all of them use alternating currents. Why? Because alternating currents are produced at a very high rate, and we need a huge amount of current for these generators or for these power plants, because huge amount of load is being exerted here. Huge amount of current should be produced to get the work done. And we know that in thermal power plants, what is happening, like steam is being produced, a large amount of coal is being burned, so steam is being produced, so huge amount of current is required for the production. Nuclear power plant, we know how fission fusion is occurring, and how there also we need electricity, otherwise the plant won't work. There will not be a fusion because it requires a certain temperature, a certain amounts of parameters, right? And that will not work if we don't have electricity coming at us at a huge amount per second, right? We can't have slow electricity, we can't have slow current, then it won't be as efficient. So you can just pause the video and note it down. An electric oven of 2 kilowatt power rating is operating in a domestic electric circuit that has a current rating of 5 ampere. What result do you expect? Okay. So we have the power here, an electric current of power, electric oven of power 2 kilowatt, 2000 watt power. Current rating is 5 ampere. So from here what we can get is that how much voltage it is requiring, right? Okay. So instead of that, what we can do is, our easier option here is to find the safety limit current, or how much current should any appliance take when it is put across a potential difference of 220 volt. So to calculate that, we will use P equals to VI, and here we will take P V. Power is 2000 and voltage is 220. Okay. So it is coming at around 9.09, something like that. Okay. So this electric oven will require a current of 9.09 ampere. Sorry. So uh, the potential difference here, or the plug or the circuit or the domestic electric circuit here, has a voltage of 220 volts. So therefore the current that it can take, like the safety limit of the current, is 9.09. Okay. So now what does it mean? It basically means that, sorry, this will not be oven, this will be the circuit. So electric circuit. Yeah. So what it means here is that if you forcefully put an appliance across the domestic circuit which will take 10 ampere of current, so it will produce short circuit, right? Because obviously the appliance will try to take in more current that can actually be supplied by the 220 volt domestic electric circuit, right? So this will cause short circuit and this will damage the whole circuit or the whole appliance at the same time, because it will cause a short circuit in the system. So 9.09 is the safety limit, and since this electric oven has a current rating of 5 ampere, so it won't be a problem because it's less than what it should it's less than its safety limit. Okay. What precautions to be taken to avoid the overloading of domestic electric circuits? For one, which is the most simplest, is that always parallel connections, right? Okay. So there are always going to be parallel connection. Also, always keep the safety limit in mind, right? Always when you are plugging anything into the 220 volt, see, like the 220 volt will not change, right? Because all over India this only is the standard one. So you have to put appliances in parallel in such a way so that it always is at par with the safety limit. Okay. Another thing is that you have to make sure that there are fuse connected to all the respective domestic appliances, electrical appliances. Okay. Also, in a particular circuit, so you have to basically, to avoid overloading, you have to not put too many appliances in series with each other. Even though they are in parallel, you have to space it out. Because why? Because sometimes if short circuit happens in one of the appliances, the rest will automatically be damaged, because automatically no current will flow through them, or it might so happen that short circuit will happen in the rest of the appliances. So we have to avoid putting too many appliances in the same circuit at the same time. Okay. The phenomenon of electromagnetic induction. So we know electromagnetic induction, induction of current, inducing current. So out of these, the process of charging a body, no. The process of generating magnetic field due to a current passing through a coil, no. Producing induced current in a coil due to relative motion between a magnet and the coil, and the process of rotating a coil of an electric motor, no. This is the exact opposite of electromagnetic induction. So our answer is C. State whether the following are true or false. An electric motor converts mechanical energy into electrical energy. No. Because why? Motor means See, the term motor is meaning only that mechanical energy is being produced, right? So this will be false, because in an electric motor, electrical energy is converted to mechanical energy. Generator works on the principle of electromagnetic induction. Yes, because we generate current, which is the whole principle of electromagnetic induction. So this is true. The field at the center of a long circular coil carrying current will be parallel straight lines. Yes, we had talked about this when we discussed the magnetic field through a circular current carrying loop. We saw that here at exactly the center it will be north to south, and here accordingly it will be like this. However, the field lines are there, north to south. So at the exact center it will be exactly parallel straight lines rather, and slowly towards the edges it will get curved. So this is true. A wire with green insulation is usually the live wire of an electrical supply. No, this we studied in the last class only. That, what did we study? That live wire is red, we studied neutral wire is black, and we studied that green wire is earth wire, or the wire which takes the excess current and supplies it right through the soil into the metallic plate that is placed far below the earth, far below our reach. So this will be false. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is pushed into the coil, withdrawn, and held stationary? Okay. So let us draw a coil of insulated copper wire connected. So it is almost like they are basically saying that it's a solenoid, but since they have not mentioned the n number of turns are present, you can just give any number of coils. So the bar magnet is being pushed into the coil. What is happening? So a galvanometer will have obviously an arrow. So if it is pushed rapidly, it will always produce a deflection, right? Because why? Because a magnetic field plus motion plus the force due to the magnetic field will induce current by Fleming's right hand rule. So there is induction of current. So let us just assume that when it is pushed inside the coil, there is deflection towards the right. Just for example, so there will be a deflection towards the right. Now it is withdrawn from inside the coil. What does withdrawing means? Obviously it is gone to the opposite direction. So now what will be the logical answer? The deflection is in the opposite direction. Why? Because there is still a motion, there is still a presence of a magnetic field, as a result of which there is still induced current, but in the opposite direction. So it is placed. So the deflection occurs in the opposite direction. Okay. Held stationary inside the coil, there is no motion. Even though there is a magnetic field, there will be no current produced. So what will be our answer? Pushed into the coil, deflection occurs. Withdrawn from inside the coil, deflection occurs, but in opposite direction. Finally, held stationary inside the coil, no deflection because no current produced. Okay, so these are some conceptual questions that can be asked from this chapter. Mostly they will be about the safety limit of every electrical appliance, nothing greater than that. So in our next session, we will just talk about some energy sources, conventional, non-conventional energy sources, and that will bring us to the end of the class 10 curriculum. Thank you.